Hi guys, this is the third video for factorization with substitution from Khan Academy. However, this particular video actually doesn't have a third problem, but I wanted to include this problem because we haven't seen one of these cases. We've seen the first case where we have three terms separated by two plus signs. We've seen the case where we have two terms separated by minus, but we haven't seen the case where we have three terms separated by minus and a plus. So I wanted to do a problem like that. So that's the purpose for this video. So as you can see, this is a problem that I'll be factoring, and I will be using the second case here, the second identity. As we've done in the past two problems, we set the original problem equal to its potential identity. In this case, we say that it looks more like this one than the other two. So we set each corresponding term equal to its corresponding term. All right, so we have 64y to the 6 equals u squared, 48y cubed equals 2uv, and 9 equals v squared. In the first equation, we're going to solve for u. In the second equation, we're going to substitute u and solve for v. And then in the third equation, we're going to solve for v and see if it matches our answer for the middle equation. I take the square root of both sides. If I take the square root of 64y to the 6, I have my scratch work over here, and I kind of took some shortcuts. Instead of doing the full prime factorization for 64, I didn't have enough space in my scratch work section. So I know that 8 times 8 is 64, and I know that the square root of 64 is 8, so I kind of took a shortcut there. But on your paper and pencil, I recommend you go ahead and expand it out with all of the 2's, and you should have 6 2's, and you get the same thing, okay? So for this pair of 8's, I'll take 1 out. For this pair of y's, I take 1 out. For this pair of y's, I take 1 out. For this pair of y's, I take 1 out. So my final answer here is 8y cubed, okay? So this is 8y cubed. The square root of u squared, as we know, is u. So we found u equals 8y cubed. Now we're going to substitute u over here, and we're going to solve for v. So 48y cubed comes down, 48y cubed comes down, 2 comes down, but instead of u, we're going to substitute 8y cubed. 8y cubed, and then v comes down. Okay, we have 48y cubed. 2 times 8y cubed is 16y cubed times v. Now here we want v, so we need to divide both sides by 16y cubed. So we have 16y cubed divided on both sides. And here the y cubes will cancel out. 48 divided by 16 is 3. Over here 16y cubed cancels out as well, and we're left with v. Okay, so v equals 3. All right, finally, we're going to solve for v here and see if we get 3. We have v squared, so in order to cancel out that square, we're going to take the square root of both sides. The square root of 9 is 3. The square root of v squared is v, so we did in fact get v equals 3 for both of these. That means that we can use this form. Remember from our quadratic identities that u squared minus 2uv plus v squared is the same as u minus v squared. This is the factor form, and this is what we'll be using to complete this problem. Here I've written it out for you. U squared minus 2uv plus v squared equals u minus v squared. All we have to do is substitute. We know that u is 8y cubed and v is 3. We substitute those here. 8y cubed minus 3 squared. And this is our final factored form for 64y to the 6 minus 48y cubed plus 9. If you factor this, you would get the quantity 8y cubed minus 3 squared.